Or have your attention yet? Why are we looking at the Titanic underwater? What does this have to do with calculus? You're about to find out. Welcome to Module 11, Week 11. I know this is going to shock you, but we're going to sum stuff up. Know what you're thinking? What stuff? Exactly. That's the question you have to be asking. What stuff are we summing up so that we need these infinitely many, infinitesimally thin slices of something in order to sum up to answer a question? Well, this week, our work is going to involve fluid force, moments, center of mass. Now, the whole point of all of this, these last several weeks, now, well, the whole course really, but it's really been a focus this last several weeks. The focus has been on the summing stuff up and this idea of seeing a real world situation, relatively real world, and thinking about volume and arc length and even in polar coordinates, and then density, mass, and work, and then now fluid force moments. It's in my brain, it's all the same idea in terms of summing stuff up, but now we're just going to apply it and think about it in different contexts, but the way of thinking should be the same throughout. Well, let's see. So let's dig in. Just want to take you through a quick tour. I promise I'll go as fast as I can. It's Module 11. Take a look at the quote. Take a look at the tip. And then a little bit about this module, moments. What does that mean? And center of mass. It's moments are kind of like work. It's a definition. You might even recognize force times distance, but a different kind of force to cause a different kind of action. You'll learn about it as you keep going. But yeah, fluid force comes first, thus the connection to the Titanic. I want you to start thinking about being underwater. And so to motivate the idea, I'm going to ask you to watch this brief video, because when you start thinking about being underwater, it can help kind of generate the thinking. Just a reading slide here about pressure underwater, and then found this physics video just to kind of get at the idea about liquid pressure. So I'd like you to watch that video. And then, yeah, we talk about the Challenger Deep. It's the deepest part of the ocean that man has discovered. And then there's a little slide here that is more of a reference slide. It's in the textbook. You can go find it. But I put it in here just as a reference because you're going to be doing things about fluid pressure and force. And when we do it, our measuring units, there's SI units like kilograms and cubic meters, when force is measured in newtons, or there's the British units where we have pounds and feet and more probably recognizable units for most of us. Not all of us. All right, so that was just a resource slide, but then we're going to start getting at some examples here. So after you've done all the work previously, there's a little problem here that you can think about and try. And as you see here, let's see. Please use paper and pencil as if you were taking notes in the classroom. Like, really work on this. Of course, then I will give you the solution on the next slide, but don't jump ahead. Try to do it yourself first. And this is just a fun slide. Can you handle the pressure? Because we're going to get into this thing about summing stuff up. Because up until this point, here we are on slide 13. Up until this point, the idea was just to get your brain wrapped around. If you've never been scuba diving, or if you've never been an oceanographer, maybe you need some just to get your mind around what we're talking about when things are happening underwater. But now, finally on slide 13, this is where the calculus comes in. It's time to sum stuff up. So there's a little video from one of our colleagues, David Lippman, and now you try. Consider the problem on the next slide, work, and then as I ask you so often, when you reach a dead end, go to the video solution I've provided. Stop the video, return to your work, go back to the video, stop the video, go back to your work. But as you progress through to slide 15 now, as you progress through the learning, I want you to be an active learner. I want you to try stuff on your own so that you're engaged in this learning process. All right, so the problem is about the yellow submarine. We all live on a yellow submarine, a yellow submarine. And this yellow submarine has this circular window. And let's say that this yellow submarine, the seahorse, was actually underwater, such that the center of that circle was 8 feet below the surface of the water. And you're going to work to find the hydrostatic force. So start working based on what you saw in the videos and see how far you get. Play a little bit of the video, stop, go back to your work, etc. The video is here. It's a pen cast of my solution. All right, and that's it. Bonus section about scuba diving, trying to keep the theme here, and then you're ready to move on. There is a 5-question quiz just to test your understanding, and then we'll get into the homework. Well, here's the textbook information, more videos if you like, access to this section, and then the homework. Again, at least 3. What do we have here? We have 6. So you do half. Challenge yourself. Maybe start with 38. Ha! Start with 38. Work your way back. Wouldn't that be something? Challenge yourself, though. Do your best. Check your solutions. All that stuff. But now, I want to try something different this time. You guys, it's week 11. You've been summing stuff up for a long time now. And what I'd like you to kind of challenge you with, and I mean this in a good way, in an encouraging way, I'd like to challenge you with something here. So what I decided to do is this. A previous time that I taught this course, I made an assignment for students because they've been summing stuff up for so long that this whole way of thinking was like a thing, and I wanted to put it to the test. Could students tackle a topic that I haven't taught them, and could they create the Google slide deck that would tell the story of the idea of moments and center of mass? But for this course, what I decided to do is, instead of have you create the slide deck, I want you to review the Google slide deck from one of the groups from a previous Calculus 2 class. So you'll read all this carefully, I know, but the idea was this. Hey class, make a Google slide. Like you've seen, what, 10 of mine now. By the time you get here, you'll have seen 11 of my Google slide decks. You've seen how I've tried to take you through the unfolding story of the idea of, whatever, work or whatever the thing was. Now, these students were asked to do the same for the idea of moment and center of mass. So they had to kind of do their own research and then put together a Google slide deck so that we would have a well-communicated, professional-looking slide deck, hoping that the ones I create are somewhat professional-looking, that would help a student to learn about these ideas, moments and center of mass. And I asked them specifically, because of this idea of summing stuff up, I asked them to, in their slide deck, specifically address what is the stuff being summed up when we talk about moments and center of mass. And because of integration, we have this idea of infinitely many, infinitesimally thin somethings. What is the something when we're talking about moments and center of mass? And then we talk about like slices. We're going to slice this up and have, like you've seen, cylindrical discs or shells or washers or whatever. What is a slice in the context of moments and center of mass? So in their slide deck, they had to kind of teach the idea, unfold the story, but make sure that these 3 questions were addressed somewhere, somehow in the slide deck. So here's your task. Instead of making the slide deck, you are not making the slide deck this time. This time, what I want you to do is review the slide deck below from a previous class. Review it. And as you review it, of course, I hope that you're going to engage with it and interact with it and learn about moments and center of mass with it, but learn it in a different way. Kind of come at it from a different angle of a reviewer rather than just a student. So what you'll do is write a substantive post describing the extent to which the 3 questions were addressed. These 3 questions up here about the stuff and the slices, all that. So give some feedback. Now, not just good job. That's not helpful feedback. Some substantive feedback describing the extent to which this happen. And then in your review, actually answer the questions. Like, I hope that as you go through this slide deck, you will actually be able to some extent, because this is your first shot at seeing this material, but to some extent, you should be able to see something about the stuff, something about the some things, and something about a slice. And you should be able to try to answer the 3 questions in your review post. All right, then after you post, you'll see everybody else's post, but rather than just kind of leave it open, I'm going to ask you to do this. Find the person below you on the class roster. All right, so if you go back over here to people, you will see a list of, guess what? People. So find your name, and I would like you to review the person below you. You can skip me. Review the person below you on the list. Now notice you might see somebody that's inactive, and if somebody is inactive, then skip over them and go to the next active person. So find the person below you on the list that is active, and you're going to review their post. So again, another opportunity for you to engage with this material in a different way. I'm hoping just to have something fresh and different to review, to engage in the topic of moment and center of mass. I lost myself here. And when you respond to their post, then notice what it says here. If the answer to the 3 questions is correct, like let's say you review the person below you and you're like, yeah, nailed it. Same thing I thought. Great. Okay, but say so, but also be specific. Find some aspect that makes sense to you and clearly explain how and why the response makes sense to you. So you guys, for those of you who like to write like half a sentence, I'm expecting more out of you in this project. I want you to like dig in, and really I'm pushing you, encouraging you to write in a professional way. Please, complete sentences, capital letters at the beginning of a sentence, punctuation even. Not text message language, but like professional academic writing here. You're going to engage with somebody and give some substantial feedback. Now, if you read the person below you and something's just not crystal clear, would you point it out? This is not to be mean. This is to be helpful. So say something. Maybe you read their post, you're like, oh, what? So maybe you have a question. If something is not clear, not connecting with your ideas, please bring it up. Perhaps you could ask a question. Perhaps you could specifically indicate which part of the post is lacking details. And then finally, if any of the answers is incorrect, say you read something, you're like, no, that's not even correct. Well, then politely and respectfully let your partner know. I want you to know that in terms of educational research, there's one researcher that I follow that says mistakes are to be expected, respected, and inspected. That's how we learn, is by making mistakes and then revising and editing and relearning. So we learn from a mistake. So I want you to identify mistakes, call it out, and encourage your partner to think about it in a better way. All right, now to try to help this whole process work well, I'm going to ask you, can you please make your initial post by Thursday at 9 a.m. so that partners aren't waiting? Like if I just have everything due Friday at midnight like normal, I can just see the disaster of people posting their initial post Friday at 11:45, leaving no time for a partner to do the response. So we'll have a dual due date here. So first, your initial post by Thursday 9 a.m. and then feedback by Sunday midnight. So I hope that leaves some time during like a typical work week, Monday through Friday, but also there's a weekend if you need it. Now here's what would be best. Engage early. So if you could get on this and even do your initial post earlier in the week so your partner has some time to do some response, that would be great. Hey, can I ask you to just kind of relate to what I'm trying to get at here, some learning? And the more you are engaged in the learning process, the thinking, and not just passively watching videos on the screen that I post. And I'm trying to find different creative ways to do that. And so in this online world. And so I thought of maybe this would be something different that you could do. Reviewing somebody else's Google slide deck, answering the questions, the big 3 questions where calculus comes into play, and then reviewing a post of a partner. And so everybody has a partner in this, and you can review the post of the partner. So if you can, do it early and engage in the learning process and help your partner to not have to wait till last minutes to get their work done. All right. I don't know if I said this. I'm going to say it again just in case. But on that list of people, so you're reviewing to the person below you on the roster. So the person who's on the very bottom, I can't remember who you are, but the person on the bottom, you're going to jump back to the top. And you're going to review the person up at the top. Sound good? Engage early. Engage often. Stay in touch. If you have a question, please ask.